Hey guys, how's it going? Mr. Simonini here. This homework assignment is all about really mixing the idea of graphing in standard form and solving in standard form. And there's actually some vertex form that's thrown into this homework assignment. So it's a little bit of a review of what we did last week and what we're doing this week. So it's a good homework assignment. Now, just to remind you, remember when we're trying to graph, the most important thing that you have to be able to recognize is, hey, when you're graphing, you want to find the vertex. So do not forget the x of the vertex is the opposite of b all over 2a. And once you find your x of the vertex, in order to find the y of the vertex, you plug the x of the vertex into the equation. Now, if you're solving or finding solutions, or if you're finding x-intercepts or roots or zeros, understand this is when we are going to use the quadratic formula. So you just got to make sure you have to read the instructions. If you're not reading instructions when you complete problems, you might be doing the problem wrong. Now, I already have some problems done for you here because I just want to make it a little bit more quicker. So again, you're going to have to do number 1. I did 2 here just to show you and kind of just talk about it. What you're doing is you're graphing and then we're finding the solutions. Remember, the solutions are x-intercepts. So it's important to graph first and then just look to see what your x-intercepts are. Now, if you wanted to do the quadratic formula here to get the solutions, it'll be the same thing as the x-intercepts. But anyways, you find the x of the vertex by doing opposite of b over 2a, which is negative 2 over 2 times 1, which is where we get negative 1 from. And then once we get negative 1, you plug negative 1 into the equation up here to get your y of your vertex, which is going to be negative 4. You put it in the middle of your table. Remember, use decimals.com if you need help making the graph and doing the table. You can look at the previous standard form graphing video from last week if you need help on that. But anyways, you plot these points, and then you get your quadratic. Again, your solutions, remember, your x-intercepts. So whatever your x-intercepts are, which is negative 3, and 1 in this case are your x-intercepts or your solution. So again, that's your answer on top of the graph that you had to do there. So in like 3 and 4, please pay attention. It doesn't say solve, it says find the vertex. So when you're finding the vertex, it's really extremely important to understand this is what you're doing. You're doing x equals opposite of b over 2a, and then you're plugging it in to find y, and then you're finding your vertex. So in this case, be negative 10 over 2 times 1, which is going to be negative 5. And then once you figure out to be negative 5, you plug it into the equation. So negative 5 squared plus 10 times negative 5 minus 28, which is going to be negative 53. Again, use your calculator to help you out there. A lot of you guys are trying to do this in your head, and I've been seeing wrong answers on the homework assignment, or at least like this week. So just please use your calculator to double check that you're getting negative 53 here, or getting the correct answer by checking my answer key. All right, so the next part of this is finding the roots. Now, whenever you see find the roots, this just means solve. All right, it's just a vocab word. So when you're solving, remember, you're finding the x-intercepts. Like this, there's nothing new here. So you're going to be using the quadratic formula whenever you can. But I want to talk about 2 questions. So one of the questions, and again, is actually very similar to number 5, which is what you're going to be doing for homework. But if you look at number 9, I want to bring your attention to 9. And there's actually 2 ways that you can do this. I'm actually going to go to a different document to show you here. So let me go to homework E, day 2. So this is it's the same problem. So it's number 9 on the homework. So it's number 9 on homework E, day 2, if you want to make note of that or whatever you want. So again, this is 9, homework E, day 2. So here we go. There's 2 methods. One of the methods is recognize this. Wait, there is only one x present in this problem. You can actually just solve this. So if you look here, I can actually just do arrows here. If people are comfortable with arrows or wheel, whatever you learn it. Or in other words, you can just traditionally solve it. Get x by itself. So how do you get x by itself? Well, the opposite of minus 5 would be plus 5. And that's the first step you want to do. It'd be x squared equals 25. And then plus or minus square root of both sides, and you get an answer of x equals 5 or x equals negative 5, because the square root of 25 is 5. And then you got to do the plus or minus of it. You should know that. But anyways, these are your 2 answers. That's one way of doing it, and that's actually the quickest way. So in my answer key, whenever there's one x present, I'm going to start just solving it. you don't need to do the quadratic formula, which is another way that you can do it, which is over here. Now, the quadratic formula way of doing this is, remember, you have to get everything on one side before you start naming your A, B, and C. So remember, you have to move that 20 over if you are going to use the quadratic formula. So just to be clear, this is the method 2, meaning this is the second way you can solve the problem. So it'll be x squared minus 25, because negative 5 minus 20 is negative 25, equals 0. You're using the quadratic formula, but remember, in this case, A is 1, B is 0, there's no linear term, and C is negative 25. And then again, what you do then is you just do quadratic formula. I don't know why I made that arrow curvy. Okay, there you go. Now, I already did it here to save time. I'm learning how to save a little bit more time on these videos. So if you look there, if you just plug those A, B, and C in, you do that. You know, you go to decimals.com, you plug it in. I already got plugged in, so plug it in. I get an answer of 5. Now, your other answer, if you change the plus to a minus, will be negative 5. So if you see, you get the same answer if you use the quadratic formula. So again, it's 5 or x equals negative 5. Now, I don't care which way you do it, but just be aware, when there's just one x present, you can just solve it the traditional way of solving it, like we have always done since first semester. You just have to be able to recognize that, and that's really important. But anyways, my answer here is going to be 5 or negative 5. So I'll come here to here, just to be clear. Again, actually, let's just do this. Something that you can do. I'm just going to, that will work, I guess. So come here, copy and paste. You know, I already did the problem, so that's good enough. I tried. But anyways, that's how you do that problem, okay? Now, 11 and 12 is different. You're going to be doing number 11. Again, don't forget you're solving, you're finding the x-intercept. So whenever y is present, for now, always assume y to be 0. That's something that you can assume because you're finding the x-intercept. So again, you're going to be doing 11 by yourself, but I'm going to be doing number 12 with you. Now, if you look at number 12, this is not standard form. There's not A, B, and C. This is actually vertex form, so you have to be a little bit more careful. This is what we did before we had our break. Now, again, if you want to do it to the old way of doing it with arrows, you can. So it'd be like plus 12 squared times negative 1 plus 49 equals 0. And then you do your inverse. Or you do it traditional way, meaning I'm going to get x by itself. So the first step here would be subtracting negative 49 on both sides. And then this is really important. People mess this up all the time because they just want to jump to that square, get rid of the square. You have to get rid of this negative 1 that's in front first. Do not square root both sides there. And what's the opposite of times is division. So a negative over a negative is a positive. So it's really positive 49 equals x plus 12 squared. We are going to get 2 answers here. And then you take the square root of both sides, plus or minus square root of both sides. That gets rid of the parentheses squared. Square root of 49 is 7. So this is going to be x plus 12 equals 7. Or x plus 12 equals negative 7. And then I subtract 12 on both sides, subtract 12 on both sides, subtract 12 on both sides, and I get x to equal negative 5. Remember, these are x-intercepts, or x equals negative 19. Make sure I'm good. Yep, negative 19. Remember, these are x-intercepts. So if I was going to graph this, those will be my x-intercepts. And then again, let me just show you if you do graph this. If you do graph this, again, those answers better show up as my x-intercept. So parenthesis x plus 12 squared plus 49. And as you can see, I got to zoom out, I believe. Boom, boom. Those are the 2 answers I got. Those are my 2 x-intercepts, so that makes sense. Anyways, I put in the message, the Schoology message and the remind message exactly what problems you are doing. Just to be super duper clear here, like when you get to 6, the only way that you can do 6 is the quadratic formula way, because there's 2 x's present in this problem. So whenever there's 2 x's present in the problem, you're forced to use a formula. The formula will always work actually. If you look here, you can use the quadratic formula, or you can just straight solve it, divide by 2 on both sides, and then start solving it. You can look at my answer key for the steps if you want to. But anyways, again, this is like a review of a lot of stuff here, graphing, solving, and vertex form, solving vertex form. So it's a really important homework assignment for you to do. Again, please ask questions because stuff is going to start getting mixed together. So it's really important that you make sure you're understanding what you need to do in each question. All right, thank you.